So I picked this problem for a couple of reasons. One is because it's going to be a good way to illustrate how to do undetermined coefficients to find a particular solution, but it'll also deal with how to handle initial conditions as well. So whenever we see a problem like this, we can kind of immediately classify it and see that this is a non-homogeneous linear second order ODE. And it's non-homogeneous because of the negative 6x term. And so in order to solve these, but luckily it does have constant coefficients, so we first need to find the complementary function. And that's found by, it's denoted by YC. And we find that by solving the homogeneous version of this problem. So we want to solve 5y double prime plus y prime is equal to 0. So we get rid of the x term. And we do this in the usual way, which is by using an auxiliary equation. In the auxiliary equation here, remember we replace each derivative with the appropriate power of m. So the second derivative gets replaced with an m squared. The first derivative gets replaced with an m. Then there's no zeroth derivative. And that all equals 0. And so to find the general solution here, we need to find the roots of the auxiliary equation. And we can factor in m out of both these terms. And so we see that our roots are m equals 0 and m equals negative 1/5. And so these are distinct roots. And so that tells us that our general solution, in this case, is yc is equal to c1 e to the 0x, otherwise just known as c1, plus c2 e to the negative 1/5 x. So this is, now we've found our complementary function. And in order to solve the differential equation, or at least find the general solution, I guess we should call this the complementary. In order to find the whole general solution to the original differential equation, we also need to find a particular solution. And now to do this in general, usually you look at g of x, which is this negative 6x term. And so we make a guess that our particular solution is a degree 1 polynomial. So that would be something like ax plus b. And now usually when we make our guess, we want to check, is there any overlap with our complementary solution? And in this case, there's not, right? There's no immediate overlap. We do have a kind of degree 0 term here. And so that's causing actually a little bit of overlap with this b. And it's not obvious that there would be this overlap, right? And if you couldn't see this overlap right away, you might solve this and go through and find that there is no choice of a and b. And this is because if we look at the differential equation, the original differential equation, let's try and go down a wrong path quickly. Which is assuming that, or like forgetting to multiply by x here. If we did that, then our yp prime would be a, and our yp double prime would be 0, right? And if we were to sub this in, the original differential equation, well, we would find that 5 times 0 plus a should equal negative 6x, right? And so even if you don't see the overlap, because it's really not obvious that there is any, this is immediately an issue because, well, there's no way, so this is impossible. There's no way that a can equal negative 6x, because a has to be a constant, right? So there's no possible choice for this. So this tells us our guess is wrong. So even if we can't see the overlap right away, that's okay. And maybe a lot of people did this on their homework. You go down a wrong path, it's okay, you just have to go back. And so this tells us that our guess was wrong, and the way to fix a guess is, well, you have to multiply by x. So our new guess is going to be the following. We're going to guess, all right, maybe yp is actually ax squared plus bx. And now notice this is eliminated overlap with this c term in the original, or in the complementary solution. And so let's give this a shot. So we need to plug it into our differential equation again, so we need to start taking derivatives. In this case, I get 2ax plus b for my first derivative, and my second derivative is just 2a. And now we're going to sub this into our original differential equation. And I keep saying original here to distinguish this from the homogeneous version, but this is the original differential equation we started with. And when we do that, we want 5y double prime, so 5 times 2a plus y prime plus 2ax plus b. And there's no yp term, so this should all equal negative 6x. And now here's where I saw a lot of confusion on the homework as well. From here, you want to set up a system of equations that'll tell you what a and b are. But the way that you do this is you group the undetermined coefficients, so in this case a and b, by the function of x they're a coefficient of. And what do I mean by this? Well, I mean, I have a function of x to the 1 here, and I also have an x to the 0. And so what I'm first going to do is I'm going to collect all of my x to the 1 terms. And so when I do that, all right, well, I see that this 2a is multiplied by x, and that's actually the only term with an x in it, and I can check that off. And now I want to collect, so this is all my x terms, and then I want to collect all my constant terms. And so I still have my 10a plus b, so here are the constant terms. And this should equal negative 6x plus 0. So here are my x terms, and here are my constant terms. And you do the same thing if there were cosines and sines here. If that was your function of x, you'd find all of your sine of x terms, all of your cosine of x terms. If there was an x squared, you'd find all of your x squared terms. And now you want to set them equal. Set like terms, coefficients equal. And so in this case, this is saying, well, if the left and the right-hand side are going to be equal, I have to have that 2a is equal to negative 6. And similarly, if the left and the right are going to be equal, I have to have that 10a plus b equals 0. And now I can solve the system. So the first line tells me that a is negative 3. And the second line tells me, well, 10 times negative 3 plus b, that should be 0. That implies that b is 30. And so I found my particular solution. So now we want to sub a equals negative 3 and b equals 30 into our guess for yp. And so we found a particular solution. It's going to be negative 3x squared plus 30x. Here's our particular solution. Okay, so now we found our particular solution, and we have found our complementary solution. And so the general solution, how do we get that? Well, that's the sum of the complementary and the particular. And so in this case, we go back, we find our complementary solution, which was this guy up here. And so our complementary solution is C1 plus C2 e to the negative 1/5 x. And then we have to add on our particular solution. So we could do minus 3x squared plus 30x. All right. So here's our general solution. But we're given an initial value problem, right? So we have to contend with this now. And that's what's going to help us find C1 and C2. So let's find C1 and C2. So first we can use the fact that y of 0 equals 0. So if I plug in, this is my x, this would be my y, I get 0 is equal to C1 plus C2 e to the negative 1/5 times 0 minus 3 times 0 plus 30 times 0. And so what this initial condition gives me is that, well, C1 plus C2 must be 0. Okay, but this isn't enough to uniquely determine either C1 or C2. This is why we need our second initial condition as well, which tells me that the derivative at 0 is negative 10. So y prime at 0, that's negative 10. And so I need to find the derivative in order to make sense of this. And so y prime, well, the C1 goes away, and so I get negative 1/5 C2 e to the negative 1/5 x minus 6x plus 30. That's my derivative. And now I want to plug 0 into that, and I should get negative 10. So negative 10 is negative 1/5 C2 e to the 0 minus 6 times 0 plus 30. Okay, and so if we work this all out, right, this would tell me that negative 40 is equal to negative 1/5 C2. And so C2 is going to be 200, I think. So C2 is equal to 200. And I know that C1 is equal to negative C2. This implies that C1 is equal to negative 200. So our solution, we get that by putting C1 and C2 back into our general solution. So it's y is equal to negative 200 plus 200 e to the negative 1/5 x minus 3x squared plus 30x. All right. And that had a little bit of everything in it. It had an overlap with the particular solution that wasn't obvious at all. And that was okay. We just went down the wrong path for a little bit. And we realized that, well, we have to go back. And that's okay. If you have to go back, you have to go back. Or you could have noticed the overlap from the beginning and multiplied by x to fix it. But the answer is always to multiply by x. Then we went through, we found our derivatives, we plugged it back into the original differential equation. And when we did that, in order to set up the system, we grouped by the function of x that the coefficient was next to. And so in this case, there was an x term and an x to the 0 term, and we grouped our terms in that way, and then equated the like terms. That allowed us to find our a and our b, which we put back into our particular solution. To find the particular solution, we add those together to find the general solution, and then we use our initial conditions to find C1 and C2. And so this is a long problem, but it kind of illustrates everything that we've done so far up to undetermined coefficients. Please let me know if you have any other questions.